Uh, Good morning, my dear students. Today we'll continue with this next portion of your highway engineering, module 2. So, can we just go through the whatever things you have studied? Okay, just we'll go through one by one about all those things, and we'll continue with the next. So we have studied about camber. So what is camber? Camber is a transverse loop provided in the road surface for the purpose of drainage. And again in camber we are having three different types: straight camber, parabolic, and a mixed camber. The straight camber is you can see the figure of the straight camber. The lines are straight here, and the slope is given 1:n in the straight camber. And a parabolic, it is in the shape of parabola, so it is called as parabolic camber. It is a combination of straight and a parabolic. So parabolic portion will be there at the center, and a straight portion at the near to the edges. Okay, and the ranges of the camber, how much the camber has to be given with different type of roads and a class of roads here. So this we have studied briefly in a previous video lecture. So maybe you came to know that why it is 1:15, 1:60, all those things, why these values are changing, why they are not kept constant. Okay, this thing you came to know, isn't it? So why the value has been changing from 1:50 to 1:33? So what is the changes? What is the purpose of this range has been changing? So you may know. I have explained in the previous video lecture itself. So if you if you are having any doubts regarding this, you can contact me at any time. So regarding any point of the doubts which is going to be occur in your mind, then it is a carriageway or width of carriageway width. So in this, basically the permissible width of the vehicle should be the 2.44 meter. How much it is? 2.44 meter is the permissible width of the vehicle, isn't it? Vehicle should not be more than 2.44. So whichever vehicle you are going to manufacture, that width should be less than 2.44. Okay, so again, if based on that, the width for a single lane, it is 3.75. How it is 3.75? It is width of the vehicle plus the clearance on the left hand side, clearance on the right hand side. Okay, so you can see here figure in this single lane road. It is totally 7.5 meter width. In that they have considered the width of the vehicle as 2.44. They have taken a round off as 2.5 meter plus 0.625 meter on the clearance on one side and 0.625 meter clearance on the other side. So collectively it is 7.5 meters. Okay, again for different lanes or two lanes it is 2.5 meter width plus 1 meter at the center clearance, and again 2.5 meter width and center clearance, again edge clearance it is 0.5 meter and 0.5 meter on the other side. So collectively, if you want to do with a multi-lane, then the width of one lane you should consider as 3.5 meter. Okay, 3.5 meter. If you are going for the multi-lane, if the 2 lane, 3 lane, 4 lanes, if you are going, then width of each lane you should consider as 3.5 meters. Okay, then we have studied about medians and a traffic separator. That means we are whatever you calling it as divider. So what is the purpose? To separate the traffic, so moving on one side and the other side. So to separate that and to avoid the head-on collision between the vehicles, we are going to provide the separators, traffic separators or dividers. Again we are having the curbs. Curbs means it is on the edges. To separate the road from the footpath to the carriageway, these curbs has been provided, and also these curbs are helpful for the drainage purpose. Means to provide a proper drainage, so that these curbs has been provided. Again, in curbs we are having the different types of curbs. One is low mountable, high mountable, semi barrier and barrier type of submerged curbs. This also we have studied. Then road margins we have studied, shoulders, parking lane, bus bay, service road, cycle track, footpath, guardrails. Guardrails, whether you're clear about this guardrail? Guardrail means you may have seen that in highways, whenever highways, this function of the guardrails is to avoid the vehicle to move away from the road. This is a support. Okay, so if any, this you can usually see whenever in highways their road is at the higher level and the next ground is at the lower level. So there is a lot difference between that road and a ground level. So in such cases, if in case of emergency or in case of accidents, the vehicle should not fall into that one. Okay, so that these guardrails are provided. These guardrails are provided to some extent. At least the vehicle should be there on that road. These guardrails are provided. This is provided at the edges of the road. Lay-by, frontage roads, this also studied. When width of the formation we have studied. Right of way we have studied. Now we'll have to go with this sight distance. Sight distance means it is the safe and efficient operation. It is for the safe and efficient operation of the vehicles on the road. Depends very much on the visibility of the road ahead of the driver. It is so safe and efficient operation of the vehicle on the road, and it depends on very much on the visibility of the road ahead of the driver. Means when here the user of the vehicle, user of the roads, that is the driver should get such a visibility on a road so that he can overtake, he can stop the vehicle, he can move the vehicle. Based on that, this is sight distance. Means it is visibility of the road to the driver. Again, in sight distance we are having different types: stopping sight distance, overtaking sight distance, intermediate sight distance. That we'll study here. Restrictions to the sight distance means if you are going to stand on a road, whenever your vehicle is traveling, if you have become the driver of that vehicle, you can see the length of that vehicle, up to what extent you can see, isn't it? So that you can speed the vehicle, you can lower the vehicle based on whatever the visibility you are going to see. So suddenly if there is any cross, if any turn will be there, but you can't observe that, if any suddenly turn will be there, in such cases you will have to slow your vehicle, isn't it? That distance, that is called as sight distance. Visibility of the driver on the roads, that is sight distance. Again, for a sight distance there is a restrictions. How the restrictions, again, what are the different restrictions we are going to study here. In case of horizontal curves, when the line of sight is obstructed by the objects at the inner side of the curve. Okay. You just imagine that there is a L shape of curve, horizontal curve is there. It's a L shape of horizontal curve. Okay. In such cases, when you are going on one side, you are going to visibility will be there up to that turn. Apart from that turn on the other side. So if you are moving, let us consider north, south, east, west. You are moving from north towards south. Again, from south towards east, there is a road. South road is what? East towards north towards south, and south towards east, there is a road. Okay. When you are moving from north side, the point you can see is south, isn't it? But you can't see the vehicle moving from east to south. You can't see. Okay, so if there is no obstruction between them, you can see. But if any inner side of the curve, if you are having obstruction, means you can't see that other side whether the vehicle is coming or not. You can't see. That is called as the restriction. That comes under restriction. At a horizontal curve, when the line of sight is obstructed by the objects at the inner side of the curve, here the sight distance is measured along the center line of the horizontal curve. When the vehicle driver is able to see another vehicle or object on the carriage way. At the vertical curve, and one more scenario is there when you are going to have the vertical curve. So vertical curve means, you just imagine that you are going in a hilly regions. You don't consider in that there is a curve and nothing at all. So there is a straight hill will be there, and you can see from one side only up to the top of the hill, but there may be another vehicle which is going from that side to this side. You can't see. You can see only from your vehicle. You can see only to the top of the hill. Okay, that is on one side. On other side of the hill, you can't see whether there is a vehicle is coming or not. That is called as obstruction in a vertical. At a vertical curve, the line of sight is obstructed by the road surface of the summit curve. So that curve, what we call it, is summit curve. For example, that is vertical curve of the road with convexity upwards. Convexity, convex, concave, convex. I think you all studied about concave surface and the convex surface. Okay, means it is a convex type of surface. Convexity upwards. Okay. In this case, also the sight distance is measured along the center line of the vertical curve when the vehicle driver is able to see another vehicle or object on the road. At an uncontrolled intersection, when the driver from one of the approach roads is able to sight a vehicle from another approach road proceeding towards the intersection, here the sight distance for each vehicle driver is the distance from the position when the two can see each other up to the intersection point of the two roads. Intersection means this is intersection of the roads. Okay, which example shall I give you, people? I think you have seen at Bhogar West there is a intersection exactly in front of the Sangeeta mobile shop. Okay, there is a curve, isn't it? There is a plus type of curve is there, intersection. Okay, so here what they are telling is vehicles are moving from Bhogar West to Chennamma. Just you can assume the example. The vehicle is moving from Bhogar West to Chennamma. As I know, when the near to the intersection, there may be another vehicles is moving from that from Samadevi temple towards that road on the other side. Okay, but the sight distance is the one when these both drivers can see each other. Okay, when both drivers can see each other, from that point whatever the distance is there, that distance is called as sight distance. That is from the point when both the drivers can see each other or visible to each other, one another, from that point to the curve, to the intersection on the both the side, that distance is called as sight distance. Next, again in types of the sight distance available from the point is the actual distance along the road surface over which a driver from a specified height above the carriageway has a visibility of stationary or moving objects. There are three types of sight distance situations are considered for the design. One is stopping sight distance. Second is stopping sight distance. Another is intermediate sight distance. Third is overtaking side distance. What are the three different type of side distance? Stopping side distance, or intermediate side distance, and overtaking side distance. Headlight side distance is the distance visible to the driver during the night driving under the illumination of headlight. Safe side distance to enter into the intersection distance. Now we'll study one by one about the stopping side distance, intermediate side distance, and overtaking side distance. First one, stopping side distance. The factors on which visibility or side distance depends on. It is a minimum distance visible to the driver ahead or side distance available on a highway at any spot should be sufficient length to safely stop a vehicle traveling at a designed speed without collision with any other obstructions. Therefore, stopping side distance is also called as absolute minimum side distance. This is also sometimes called as non-passing side distance. Means you are moving with your vehicle here. If you want, there is a bus stand. Okay, there is any stop will be there, or any bus stand will be there. There is the bus stand or that spot should be visible to the driver in such a way that he needs to stop the vehicle. He needs to stop the vehicle at that point. For that, whenever the driver need to apply the brake, the vehicle will not stop immediately, isn't it? Vehicle will not stop at immediately. Okay, when it will be stop at immediately means when there is a friction is 100%. 100 friction between the tire, between the road and the vehicular tire is 100%. Then you can think that you are going to stop the vehicle at whenever the brakes apply. At that point only the vehicle is going to stop. Okay, that case will not be there in our road condition, isn't it? Whenever the brakes are going to be applied, whenever you want to stop the vehicle, you need to apply the brakes just some distance before, isn't it? So that vehicle is going to be stopped at that point. That is called as stopping side distance. Means it is a minimum distance visible to the driver ahead or side to the distance available on a highway at any spot should be the sufficient length to stop the safely to stop the vehicle. It is the distance visible to the or available visible to the driver to stop the vehicle at any spot on the highway. You can call it like this also. Therefore, the stopping side distance is also called as absolute minimum side distance. So this is the minimum distance required to stop the vehicle. Okay. Again, it depends on the various factors. The side distance available to the driver traveling on a road at any instant depends on the following factors. One is features of the road ahead. Means what is the kind of road it is, features of the road, and height of the driver's eye above the road surface. It is height of the driver's eye above the surface. Okay, so when the driver is at the higher distance, he can visible to the long distance. Okay, when he can visible to the long distance. But if the vehicles are having lesser height, then the driver visible height will be less. He can see a smaller distance. Okay. So that is also one factor, that is height of the eye, driver's eye above the road also comes into picture here. The height of the object above the road surface, same case. IRC has suggested that eye level of the driver as 1.2 meter and height of the object as 1.15 meter above the road surface. What IRC suggests? What IRC means, it is Indian Road Congress. We have studied in first module about what are the different bodies which are being formed for the development of the roads, isn't it? So in that the IRC is also there. So IRC is what IRC is doing is it gives the specifications of the road. Okay, so for the specification again they have given for this is the eye level of the driver is at a height of 1.2 meter above the ground, means height of the eye level of the driver is above ground, it is 1.2 meter, and height of the road above the ground level it is 0.15 meter. That is what the IRC has suggested. Minimum vehicle should have this much distance. If you are having more than that, it is well and good. Okay, minimum you should have so much height and that distance. Clear stopping side distance. In general, if I want to explain, I want to tell in general means it is the distance required to stop the vehicle. It is the distance required to stop the vehicle safely on the highway or a road. It is the distance required to stop the vehicle safely. Okay, this is called as stopping sight distance. Again, we'll study here what are those. These are the how the sight distance will be depends on means 4 factors. One is the type of road it is, and the visibility of the driver's eye, height of the driver's eye above the road surface, height of the vehicle above the road surface. But here how the factors on which stopping sight distance depends. The distance within which the motor vehicle can be stopped depends upon the following factors. One is the total reaction time of the driver, speed of the vehicle, efficiency of the brakes, okay, frictional resistance between the road and the tire, and a gradient of the road. Factors which are going to influence the stopping sight distance are total reaction time of the driver. Again, reaction time of the driver means whenever he is going to suddenly see that there is a stop, there is a in mind he will have to think that I need to press a brake to how much extent, so that he will that in that at that point of time he needs a time that is called as total reaction time. Okay, we'll discuss this total reaction time briefly here. Again it has been categorized into two: perception time and reaction time. We'll discuss about this one. But total reaction time means whenever you are going to see a stop, at that point there is a mentally the time required for a driver to stop that vehicle. Okay, that is total reaction time. Then the speed of the vehicle. So obviously whenever you want to stop the vehicle, it obviously depends upon the speed of the vehicle. If it is slow, you need less time, less distance to stop the vehicle. Okay, easily you can apply the brake and you can stop the vehicle. But if if your vehicle is very speed, then you need more distance to stop the vehicle, because you can't apply that suddenly 100% brake, so that there may be overturn or skidding of the vehicles. There may be such possibilities will be there, isn't it? So again, your stopping sight distance depends upon the speed of the vehicle, total reaction time of the driver, efficiency of the brakes. What I have told, suddenly when you applied the brake, if the vehicle stops at that point itself, means it is 100% efficient. That it means brake efficiency is 100%. Otherwise the efficiency will be differ. Okay, that only this will be depends upon different vehicles having different type of brake system. Again, the different brake efficiency will be there. That also will come into picture here. And also frictional resistance between the tire and the road. And also gradient of the road. So okay, gradient In gradient we are having two possibilities. One is upward gradient, one more is a downward gradient. In upward gradient, obviously your speed of the vehicle will be less, then you need a lesser distance to stop the vehicle. But in case if you are going on a downward gradient, your vehicle will be at a higher speed and okay, so that there is obviously it takes more distance, okay, to stop the vehicle. So that will also come into picture. We will study one by one briefly here. So first is reaction time of the driver. So reaction time of the driver is the time taken from the instant the object is visible to the driver to the instant when the brakes are applied. This total reaction time may be split up into four components based on the PIEV theory. So whatever the total reaction time is there, that you can split up into four types based on PIEV theory. In practice, all these times are usually combined into total perception and reaction time suitable for the design purpose as well as for the easier measurement. Okay, reaction time of the driver means when he is going to see the object or object is visible and instant when the brakes applied, that time duration is called as reaction time of the driver. Okay, general example I will give. Whenever you are going to see a snake, whenever you are going to see a snake, you need some fractions to react. That fractions is reaction time. That is for general. Same way, in our vehicles also, is the driver when he can see or spot the object on the whenever you can see a object on the road surface, he need certain time. Okay, he needs certain time to react. That is called as reaction time. What the reaction may be either to press the brake or leave the bus, isn't it? So whatever the reaction is going to take, that instant duration is called as reaction time. Again, this reaction time has been split up into two parts: perception time and brake reaction time. Perception time, it is the time required for a driver to realize that brakes must be applied. It is a time from the instant the object comes on the line of the sight of the drivers to the instant he realizes that the vehicle needs to be stopped. The perception time varies from driver to driver. Again, this will be depends upon the driver to driver, and also it depends upon several other factors such as the distance of the object and other environmental conditions. Next is brake perception time. Now brake reaction time, it is also depends on the several factors including the skill of the driver, the type of the problem and various other environmental factors. Perception means when you are going to see, that is called as perception. Okay, perception time means it is the time from the instant when the object comes to the line of sight of the driver to the instant he realizes that the vehicle needs to be stopped. This time is called as perception time. Reaction time means after applying the brakes, that is distance is called as, that time is called as brake reaction time. Now the PIV theory will study in the next video. So I think the doubts are, if you are having the doubts in this so far, you can ask me. I will clarify your doubts here. Again in the next video lecture, again I will come with I will just report with whatever we have studied and will continue. Thank you.